Hello everyone. In this video we are going to study a new topic, that is boundary description and object recognition. Now this is the major part of your image processing in order to recognize the object, pattern or texture. So there are many applications that you will require in order to recognize the pattern or texture, in order to process the image, in order to modify the image, in order to improvise the image. Okay, in order to make that image very suitable for your application. Okay. So this module is divided into two types, that is texture uh, recognition, or how to extract the features of from the texture, and the object recognition based upon the knowledge. Okay. Now what is the texture? The texture, if you have the texture pattern like this, if you have extracted the texture pattern from the image like this, and if you are selecting the particular area from the texture pattern, and you can see it is made up of multiple intensity values. You cannot create a texture for a single intensity value. You require multiple intensity. They are piled up together, or you can say they are combined. You need to consider the accumulation, you need to consider and all the pixels together in order to generate a pattern, and in order to study the pattern recognition or texture recognition. Okay, so texture cannot be defined for a single point. The texture is a repeating pattern of local variation in image intensity. Okay. Now, in this example, if you see at three types of image, you will find there are they are made up of black pixel value, black pixels, and white pixel. Okay. Now, if you have a black pixel, they are situated in this space of an image. There are a different kind of placement of a black pixels and a white pixel in three types of images. If you consider a first image, in this image the black pixels are located in this spatial area of the image, and if you consider the white pixels, they are situated like this. So 50% of your area is being covered by your black pixels and 50% by white pixel. Similarly, if you look at the second image type, you have the alternative pattern for white black white black. So the pixels are located, pixels are actually situated alternatively right after black and white. So this is the alternative arrangement in a space, image space. This is also the alternative arrangement, but you're using little proportion, or little, or the group of intensity values, and you are placing this group of values together alternatively, and you will be able to create this pattern. So it is not necessary if you have the same proportion of intensity distribution, or you can have a same intensity distribution, you won't get a same texture. Okay, this is a different kind of image. In this image you can see that these are nothing but the rivers, pebbles. It will provide you a different, so there are different types of aspects. From that you can decide the texture. Okay, so texture is a set of texture element. They are also known as primitive or texels. They occur in some regular or a repeated pattern. Okay, you may get the regular pattern or a repeated pattern or irregular pattern. The texture can be anything. So texture refers to properties that represent the surface or structure of an object. Okay, we might define texture as something consisting of a mutually related elements. Texture consists of a texture primitive or texture element. Yes, we have already discussed. And the main aim of texture analysis is recognition. Yes, and texture based shape analysis. Okay, the main aim of the texture analysis is to recognize the pattern, to recognize the object. Okay, now if you consider the texture of a dog fur and a grass, they are using a same kind of primitive. So the primitives in grass and dog fur are represented by the several pixels and correspond to a stalk or a pipe. Okay, and it is not necessary that same number and same type of primitives they will provide you the same kind of texture. Okay, so the primitive that or the elements of a texture that you are using for the dog fur and the grass are the same, but they are not providing with the same kind of texture if you compare the texture of a dog fur and the grass. And texture is usually described as a fine texture, coarse texture, um, grained, smooth, etc, etc. Okay, suppose you are comparing the texture of cork. We have seen a cork that we have uh, in our bottles, like champagne bottle or wine bottles. So cork, it is the structure of that or the texture of a cork. It is built from a primitive that are comparable in size with a pixel. Okay, and if you compare the textile pattern, it is difficult, however, to define primitives for checkered textile or a fabric, which can be defined by at least two hierarchical level. The first corresponds to textile checks, okay, or unknitted stripes, and second to finer texture of fabric or individual stitches. So different kind of texture for the textile, and this is different kind of texture for the cork. Now you have a three pattern. Now you have a similar pixel. If you compare the image A and image B, you have a similar kind of intensity value, but the arrangement is different. If you compare the spatial location of the pixel, it is different. They are this in this image B, they are arranged in a uniform manner. Okay, and if you compare these, their locations are different. But if you compare the image A and image C, the placement of the pixel is similar. If you compare, this is as a 0 0 position. Yeah, you have a 0 0 position. There is a pattern 0 0 at 0 0 position. If it is 0 2 position, you have 0 2. This is 0 1 position. Yes, you have 0 1 position pattern. Means if you have a same kind of pixel, but if you are not following the position or if you are not following the placement of a pixel in the same manner, you won't be able to create the same texture, though they are carrying the similar kind of texture, similar kind of pixel, or similar kind of you can say the pattern, but they are not uh, exhibiting the same kind of texture. Okay, similarly, if you have the same kind of spatial arrangement, but still you won't be able to offer a similar kind of texture because you are using a different kind of pattern. This is a hash pattern, this is a flower pattern. Okay, so figure A and C show that the same spatial relationship of primitives does not guarantee texture uniqueness. Okay, this A and C. So the spatial relation means the coordinates of each and every pixel. If you're comparing this pixel, the coordinates are similar, but the spatial arrangement is similar, but they are not offering the same kind of texture. Okay, now figures A and B show that same number and same type of primitives do not necessarily give the same texture. Yes, now same type of primitive or same type of pattern, or you can say the constituents, they will not offer you unless you actually set the pattern as per the spatial coordinates. Okay, now statistical texture description. It has a first order statistics, second order statistics, and higher order statistics. Now what are they? Now first order statistics, they provide you mostly the variance, deviation, skewness, or cutis. Okay. So the first order statistics estimate properties like average variance of individual pixel values by waiving the spatial interaction between image pixel. The second order and higher order statistics estimate the relation between the uh, two or more pixel values. Okay, so these are nothing but the standard formula for mean. We already studied in image restoration. Mean, it is defined by this x bar. Mean is nothing but a summation from I1 to the final size, and this is nothing but the average. Okay, you need to add all these constituents of or all the elements from the image, and you need to divide by the total number of pixels. That will be the mean. And the variance, these are the standard formulas for the variance, skewness, and kurtosis. So you have a mean value x bar. You need to subtract this mean value from the input element, and you need to make a square of this combination and to divide with the total number of pixels, and you will get the variance or dispersion. Okay, skewness, it provides positive or negative. If you have the pattern the waveform positive or negative, it will show you the skewness. Kurtosis, whether the waveform is tall or whether waveform is flat, it will show you the different kinds of valley or peaks of from the waveform. Okay, this is the formula. These are the formula for deviation, that is input minus mean square. Same formula. If you compare this formula, this, okay, this is a square, that is why you don't have the square root. So under the square root, the same formula you will get. This is a deviation, and skewness is 1 by n, the total number of pixel, under root the summation of input minus mean and the cube of this entire bracket divided by the cube of your deviation. Now, how to analyze the different kinds of texture using a co-occurrence matrices. Okay. Now, a co-occurrence matrix is a two-dimensional array C in which both rows and columns represent a set of possible image values V. For example, if for a gray tone image value V, that is V can be the set of possible gray tones. For color images, value V can be the set of possible colors. So for a gray color image, value V represents a possible gray tones. For color image, the V represents possible values of color tones. Okay, it can be anything. For 8-tone image, 4-tone image, whatever the tone that you want to use in order to process the texture, yes, you can utilize that. Now, value of this co-occurrence matrix Cij indicates how many times value I co-occurs with a value j. Now I will show you how to do that. Now before that, we need to study some parameters like d. D is a displacement factor which is made up of row displacement, column displacement. So dr and dc. Dr represents displacement in the rows, dc represents displacement in columns. Okay, so displacement in rows, that is downward. Once you finish the column, sorry, row, you will go downward for the another row. Okay, and then displacement in a column will be like right. For each and every column you will compute the values. Okay, and we are nothing but a set of gray tones. If you're considering the color image, the V will be the set of color tones. Okay, now the formula that we need to consider is, this is the co-occurrence matrix which is made up of Ij. Okay, and it has a row element, column element, which is made up and these, the entire column and row elements will make a image. Okay, you need to match the co-occurrence or the co-occurrence of j for I. Okay, you need to actually select the angle as well as the distance. You have different types of angles. Okay, if you're considering this, I will show you in the next example. Now, suppose you have the example like this. You have a image which is made up of this pattern: 1100 1100 This is a pattern, this is the pattern of intensity values, and this is input image. Now, if you want to find the co-occurrence matrix for 0 and 1, okay, so 0 and 1. Now, 0 and 1 means 0 and 1 represents a distance d. 0 if 1 is equal to d, okay, 0d. Where is the 0d? 0d. If you are able to see that, zoom in into the video if you are not able to see that. I will show you in the next slide. That is the biggest, the larger size of this image. So for this example, I have put this the direction and the angle of this the pixel arrangement. Okay, so that you will be able to compare the input image and you will be able to solve for the co-occurrence matrix. Now for C01, now for C, that is your co-occurrence matrix of 0 1, means I value 0 and j value is 1. You will be able to solve this if you have this type of pattern or this type of diagram. So 0 and 1, 0 1, if 1 represents d, 0d, the coordinate is 0d and it has the angle 0 degree. Okay, so you need to consider the horizontal, that is horizontal orientation, ij, horizontal, from left to right, from left to right. You're going from center to right direction in 0 degree for the distance, for the parameters like 0d. Okay, 0 1. Now you need to actually find the occurrence of j for I. Now if you have 0 1, now how many times the 0 1 you will find? Now first is you need to consider 0 1. Okay, so you have to follow the 0 degree pattern. Okay, now first you will start from the 0 0. Okay, 0 0. Now 0 0 repeats how many times? 0 0 0 0 0 0 1 2 0 0 0 0 1 2, that is 1 2 3 4. You need to write 0 0 pattern, that is 0 of j repeating 0 of I 4 times in that pattern, ye pattern, that is a horizontal pattern for 0 degree. So 0 is this 0 j is repeating for I, 0 is repeating for I, this j0 is repeating for I, this, if you put a 0 0 here in this box, ij 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 ij, you have 4 ij ij combination, and you will write for 0 0 you have 4 repetitions, 4 co-occurrence of j. Okay, now for 0 and 1, 0 and 1, the coordinates for 0 and 1, how many times the 0 and 1 repeating in the image? 0 1, no, 1 0. Now you have to consider this horizontal ij pattern, 0 1 0 1 0 1. There are none of the repetition you will find in the image which will carry 0 and 1, so you will place a 0 here. Okay, now you have 0 and 2, 0 2 0 2 combination. So yes, you have 0 2 0 2 combination, it is repeating twice. So 2, that is j value, it repeats for 0 twice in the image, so you have value 2. Similarly for 1 0 1 0 1 0, this is horizontal 0 degree pattern, 1 0 1 0 twice, so you have 2. 1 1 1 1 1 1, that is 2. 1 2, there is no any 1 2, so you will write a 0. Then 2 0 2 0 2 0, there are no any, so you will write a 0. 2 1, no. 2 1 2 1 2 1 2 1, no, there is no any 2 1 pattern. Now 2 2 2 2, so 2 2 2 2 horizontal, huh? for the 0 1. This will define a direction as well as the angle that you need to consider to find the co-occurrence matrix. Okay, so you will get the C01 in that manner. Similarly, if you want to calculate C for 10, now 10, where is the 10 means you can consider D0 distance, D0 as a pattern. So where is the D0? At 270 degree, this is 270-degree pattern. So you have I, now I are situated like this and J are situated in this area at different angle. Okay, IJ, it is coming down. Okay, so IJ coming down, you need to consider the pattern like this. 1 1, if you have 1 1 repetition, you need to consider this. This is the image. If you have 1 0, D is equivalent to 1 1 0. This is 1 0. We have already solved for the 0 1 0 D, that is 0 1 0 horizontal IJ. Now you have IJ. Everywhere you will write I, and these are nothing but the J. J J J J J J J J. Okay. Now you have IJ pattern which is coming down. Okay, like this. Now again you will solve for this. The co-occurrence matrix for the I 1 0 is 1 0. Now first you need to start from 0 0 0 and 0. Now, can you find a 0 0 in this manner? Yes, 0 0 0 0 0 0 0 4 times. Yes, 4 times 0 0 pattern. Now 0 and 1 pattern means 0 and 1 pattern. 0 1 pattern. 0 1 pattern you will find no. So there is no any 0 1 0 1 pattern, vertical pattern. So 0. Now 0 2. You have 0 2. Yes, 0 2 0 2 1 2. Okay, you will write 2. Now 1 0. You have 1 0 like vertical pattern. Yes, 1 2 2 1 1. You have two patterns like vertical pattern 1 1, so you will write it 2 twice, so twice value 1 2. There is any pattern like vertical pattern like 1 2 1 2? No, no, so you will write a 0. Now you, if you can consider 2 0 2 0 2 0, no, there is no any pattern. Then 2 1 means if you consider 2 1 2 1 2 1 vertical pattern, 2 1 vertical pattern, no. If you consider 2 2 2 2 2 2, yes, 2 2 I2 J2 I2 J2, so you have two pattern. Okay, so you will write 2. Now if you want to calculate C11, now what is the C11 DD? Where is the CDD? This is the distance at angle 315 degree, so this is a diagonal. Okay,